Standard 3.2 has us to applying definitions and theorems in the process of solving a problem. When I look at Standard 3.2, I think of it as, did you use the right process, the right definition, the right theorem in order to start the problem itself? So for number 7, given that the diagonals of a rhombus bisect opposite angles, we labeled the parts measure of angle ADB and the measure of angle BDC. Did I use the fact that those two angles are congruent to write the equation 7x plus 2 is equal to 9x minus 8? That's it for Standard 3.2. Again, I look to make sure that you wrote the correct equation, again, that you use the correct properties and theorems to begin the problem itself. For number 8, same idea. In circle O to the right, A, B, and CB are both tangent to the circle at points A and C. So remember, our two tangent theorem, or our tangent segment theorem, says that when two line segments are tangent to a circle and meet at an external point, then those two segments are congruent. Therefore, AB is congruent to CB, and we can write the equation that tells us that 4x plus 1 is equal to 6x minus 7. And then finally, for number 10, let's go ahead and label everything to begin with. The measure of angle BDA is 50 degrees. That's given right here. BD is tangent to circle A at point B. BD, this guy, actually it's just this segment, so let's just mark this segment, is tangent to circle A at point B, which tells me then that I have a right angle. I have a 90-degree angle right there. And I want to know the measure of arc BF. What is the measure of arc BF? So there's a few different theorems that we need to use. The first was that the tangent to the radius, right? I have a tangent line, BD, and the radius AB create a right angle. So there's one theorem. I have another that tells me that the sum of the interior angles of a triangle is 180. So if I subtract the 90 degrees and the 50 degrees that we already have there, this little guy here is 40 degrees. I also know that a straight line measures 180 degrees and that my linear pair here is 180 minus 40, right? So this angle is 140 degrees. And then finally, I can say that since the central angle and the arc share those endpoints, they have the same measure. So this is 100 degrees. Remember, central angles are the same measure as the arc they intercept. Therefore, the measure of arc BF is equal to 140 degrees. Please make sure that you write that out for me.